The topic for Lesson 4.3 is congruent triangles. We'll name and label corresponding parts of congruent triangles and identify congruence transformations. Triangles that are the same size and shape are congruent triangles. Each triangle has 3 angles and 3 sides. If all 6 of the corresponding parts of 2 triangles are congruent, then the triangles are congruent. If triangle ABC is congruent to triangle EFG, the vertices of the 2 triangles correspond in the same order as the letters naming the triangles. This correspondence of vertices can be used to name the corresponding congruent sides and angles of the 2 triangles. So angle A is congruent to angle E, and they color-coded them red. Angle B is congruent to angle F. Angle C is congruent to angle G. Segment AB is congruent to segment EF, segment BC is congruent to segment FG, and segment AC is congruent to segment EG. The corresponding sides and angles can be determined from any congruent statement by following the order of the letters. 2 triangles are congruent if and only if their corresponding angles are congruent. Remember that if and only if tells us the statement can be read both ways. So we could also say if corresponding parts are congruent, then the triangles are congruent. For example 1, they gave us a picture of a tower roof composed of congruent triangles, all converging toward a point at the top. Name the corresponding congruent angles and sides of triangle HIJ and triangle LIK. They gave us a lot of information in that congruent statement there, so all the corresponding parts have to be congruent. So angle HJI has to be congruent to angle LKI. Angle ILK over here has to be congruent to angle IHJ, way over there. And finally, our vertex angles, angle HIJ has to be congruent to angle LIK. And for our sides, HI is congruent to LI, HJ, so the first and last letters there, is congruent to LK. I said HJ and I marked IJ. Whoops. And IJ, so the last 2 letters, is congruent to KI. For example 1b, we're starting with the same diagram and they ask us to name the congruent triangles. We kind of already did. Triangle HIJ, so we said that HI was congruent to LI already, is congruent to a triangle LIK. And we already said that HJ was congruent to KL and JI was congruent to IK. So we can see the parts are all congruent. Congruence of triangles is reflexive, symmetric, and transitive. That seems to be intuitively true enough that I wouldn't probably take your time to make you write all those diagrams down. In the figures below, triangle ABC is congruent to triangle DEF. If you slide, or a better word that we used in the algebra book was translate, triangle DEF up and to the right, triangle DEF is still congruent to triangle ABC. The congruency does not change whether you turn triangle DEF or flip triangle DEF. ABC is still congruent to triangle DEF. And a turn in your Algebra 1 book, the better term was rotation, and instead of flip in the Algebra 1 book, the better term was reflection. If you slide, flip, or turn a triangle, the size and shape does not change. These are three transformations are called congruence transformations. The vertices of triangle RST are at -3, 0, 0, 5, and 1, 1. The vertices of triangle R prime, S prime, T prime are at 3, 0, 0, -5, and -1, -1. Verify that the triangles are congruent. Okay, to find the length of RS, we can use distance formula. So I counted 5 squares here and 3 here. So I have 5 squared plus 3 squared. So 25 plus 9 would be square root of 34. For ST, I've got 1 and 1, 2, 3, 4. 1 squared plus 4 squared.
$10. Could you please come to the...
So that's going to be square root of 17. And for RT, I've got 1 and 4 there also.
Hi.
So, surprise, surprise, we have square root of 17 again. All right, let's look at R prime S prime. If I count squares, I get, 5 and 3. So that's going to be square root of 34 again. S prime T prime. 4 and 1. So that's square root of 17 also. And R prime T prime. 4 and 1. So they're both actually isosceles triangles, but they didn't ask that question. When they just asked us to verify that the triangles are congruent, we just did all the sides, and if we took a protractor, we could measure all the angles as well. I don't have a protractor, so we'll just have to take their word for it on that one. So because all of the corresponding parts are congruent, we can conclude that the triangles are congruent as well. For our last one, they ask us to name the congruence transformation that transforms triangle RST into triangle R prime, S prime, T prime. Okay, they have turned or rotated this triangle. It looks like 180 degrees. I'm going to say rotation, even though this book is writing the word turn, because it's a better math word. Okay, summing it all up, two triangles are congruent when all of their corresponding parts are congruent. So if we look at a statement like triangle EFG is congruent to triangle JKL, the corresponding congruent sides are in the same order, and so are the corresponding angles. So E to G, F to K, G to L, and the segments EF to JK, FG to KL, and EG to JL.